In this lesson, we are going to talk about React 3 Fiber, but more precisely about Dray. What is Dray? Well, I can spoil you a little. We're going to create a bunch of things, and you're going to see that it's going to be super easy. As you can see, we can play around, etc. We're going to discover everything I did in that scene right after. So I'm going to close that. This is the final result. I have the starter here. I'm going to talk about this one right after. Creating a 3JS scene is already super simple with React 3 Fiber, as you can see from the previous lesson. But it's going to get even more simple after this lesson. You will see why. One advantage of React is the ability to make things reusable. Right? There are a bunch of advantages, but one of them is to make things reusable and quite easy to reuse, also for other developers, not just for you. React 3 Fiber took advantage of that, and developers are creating many components that we call helpers ready to be used. And we are going to use a bunch of those helpers in this lesson and also in the next lessons. I can give you just some examples. So you already saw from the final project, but I can give you more examples. We can have camera controls. All right, I thought we already did this one, but you will see that it will get more simple. Complex geometries, post-processing, HTML implementation. HTML, what exactly do I mean by HTML? You will see. Loaders, environment settings, complex calculation, etc., etc. And there are hundreds of those. Some of the components will be, some are going to be implemented as components like this, like you put in your JSX. And sometimes it's going to be hooks, hooks that start with use something. Well, we get both of those. Most of them are regrouped in Dray, that we probably pronounce dry. It's the German for three. I think I would say just Dray because I got used to say Dray. Sorry if it's not the right pronunciation. Yeah, by the way, click on the link of Dray. I put the link to the repository on GitHub. It's this one right here. And I'm asking you to check those helper. All right, check those helper. There is a lot of them. Just read them. I know it's a long list. Check that, and you can check them right below. You have always an example. You can click on links if you want to see them live. Check those examples. Why am I asking that? Well, it's because you might try to do stuff that has already been done in Dray. All right, so you can just use those helpers instead of doing them on your own. It's always good to do things on your own so that you will learn, but don't reinvent the wheel. I mean, if there is an helper doing exactly what you need, maybe you should just use that helper. But you need to know that that helper exists. So check the list, just check those things, try to understand which one is doing, so that maybe you can use it later for your projects. Anyway, during this lesson, we are going to discover a bunch of them together. In the next lessons, we are going to use even more of them, so you will be able to use them properly. So about the setup, we have the basic scene that we created in the previous lesson. So we have the orange sphere, we have the purple cube and the green floor. We have the two lights that we had before. So there is the directional light and the ambient light so that it looks a bit better. And we have the orbit controls that we created in the previous lesson too. Okay. Next. So yeah, as always, to start the project, the starter, you download the starter. You run npm install to get the dependencies, and then npm run dev to start the local server. It's the same as the previous lessons. Let's talk about the orbit controls. You might think that we already added the orbit controls. Check that, it's from the previous lesson. So if you open the experience.js file, you will see that we imported orbit controls from the 3JS dependency. Then we extended orbit controls so that we can use it in our JSX. And we found a way to send it to the camera and the WebGL renderer so that it works, so that we can interact with it, rotate around. Okay, that's great. It was a bit tedious. And you will see that using Dray, it's going to be super easy to do the same thing. And I think I already spoiled you in the previous lesson. I told you that it will get a bit easier. That's the moment where it gets easier. All right, so in experience.js, first we are going to do some cleanup and remove that orbit controls we created. I know I could have removed it from the start, but I want to show you how easy it's going to be compared to doing it on our own. So first we are going to remove a bunch of things. We are going to remove the orbit control. We are going to remove the extent of the orbit control. We are going to remove the implementation of the orbit control in the JSX. And because we don't need the camera and the GL DOM element, we can also remove the call of use3. And we can also remove the import of u3 and extend, because we don't need those anymore. And we get almost nothing in the scene anymore. If you give it a reload, it's working, great, but we can't rotate around anymore. So as you can see, there is not much left. And now we want to get back our orbit control. So how do we do that? First, we need to get access to the Dray helper, all right? The list I showed you right before on the GitHub, which is right here. We have a bunch of helpers. Maybe you already read them. We have some controls, etc. How do we get access to those? We need to add the Dray library, all right? The Dray dependency. And that Dray dependency is inside React 3. I told you that React 3, so at React 3, is the scope for multiple dependencies. We already use Fiber. We're going to use a bunch of dependencies from that scope. And right now we need the Dray. It works the same. You just write this when you want to add the library to the project. So I'm going to open the terminal. I'm using the terminal from VS Code. I keep the server running, and I'm going to create a new terminal. You do whatever you want. If you want to close the server, install the dependency, and relaunch the server, you can do it. But me, I'm going to create a new terminal. And in here, I'm going to install React 3 Dray by doing npm install at React 3 / Dray, like this. So dry, dry, I think it's dry. And I'm going to specify to choose a specific version. So it's going to be 9.32. As you are doing this lesson, I guess that there are new versions of Dray. But we are forcing the version so that we are sure that we get the same result. If you want to test the latest version, you might have some bugs, some differences compared to the video. So for the sake of learning, maybe you should use the same version as me. If you remove this part, you will get the latest version, that's for sure. And you're going to have some surprises. So my recommendation is to use the same version as me. And if you get some warning errors about vulnerability, warning, stuff like that, you can just ignore those, okay? Those are most of the time totally harmless. And anyway, we are doing it in local just for the sake of learning. It doesn't really matter. Obviously, if you go live, you should update those, not just for security reasons, because if you just do like a front-end websites, it's fine. But usually it's fine. But more to get the latest features, better performances, things like that, some bugs fixed, etc. And to do that, I can give you an example. Like if you want to update this library exactly, so you already have that library on that project, so that dependency on that project, you want to update it, you replace the version by latest, right? Because if you do that, it will reinstall the same version. So if you already have it in the project, if you run that command without specifying a version, it will reinstall the same one. So you need to ask for the latest by writing latest. So at latest. Cool. I can remove that. I think I can remove that terminal and get back to the server. If you stop the server, you have to relaunch it. Okay, yeah, I told you that already. Nice. Back to experience.js. I'm going to close that terminal and I'm going to import the first helper we are going to use, which is the orbit controls. And it's going to be from that dependency we just added. So it's going to be from React 3 Dray, and it's right here. As always, you can also rely on the auto import of VS Code, but I prefer this time to write it like this, manually. And next, be prepared, it's going to be super complex. You just need to do this, and you are done. I'm going to save and check that. So the sphere, as always, disappear. I don't know why. Give it a little reload. It fits the case for you too. It has nothing to do with we have big control, but check that. It's working. We added the Dray dependency. We imported that helper, so the orbit controls helper, which is a component, and then we added to our project, and we are done. So much easier. Remember what we had to do with the first time we tried to implement the orbit controls, and we didn't have every features, like the damping was not working, and to make the damping work, it was even harder. So that's why we didn't do it. And check that now. We have the damping. See, give it a little push like that. stop touching your trackpad or your mouse, and you see that it continues. It's smoother. There are some inertia. By the way, you can control it. Like if you don't like that damping, there is a bunch of possible parameters and attributes, but I just want to show you one. It's the enable damping, and as you can see, VS Code is helping us autocomplete everything. So enable damping, which is the case by default. And if you put it to false, like this, you don't even have to reload, and there is no damping anymore. Nice, it's working. We're going to keep the damping because I think it's better, so I'm going to remove that. Feels a bit smoother. I just wanted to show you that you can tweak them. Nice. So just like we discovered the orbit controls, we are going to discover a bunch of helpers. The goal here is just to show you some examples so that you understand what we can do, so that you understand new features made possible by React 3, React, etc. and Dre, obviously. But once the lesson is done, just try some on your own, and we are going to discover more in the next lessons. It's just to discover cool stuff. Next one is transform controls, and you probably have already seen this one. It's quite a famous one that we can find in Three.js, all right? But it's much easier to implement in React 3 Fiber, as you will see, and then after we are going to see even better, but no spoiler. So transform controls, as always, I put the link, check the link tab right below, and open it if you want to see the documentation, which is just from Dre, and you have some examples. You can click on those images right here, but usually the documentation is more than enough. And so the transform controls, we add a gizmo. What's a gizmo? You will see right now. That allows the user to transform, so it's about the position, rotation, and scale, the object. Let's implement it. So right here, as we imported orbit controls, we can import transform controls. By the way, I'm going to import everything right here from that same line, but if you prefer, you can add some line breaks like that. Right? I like this too, but I don't like when I open a file to have like I don't know, like 50 lines of import. So I don't always do it. It's up to you. If you prefer to add line breaks, you can do it. We imported the orbit control, so I'm going to put back the result here, and we're going to add it. So it's to handle the position, rotation, and scale on an object. So we're going to add it to wrap the cube in it. So the cube is right here. It's this one. It's the second mesh. And I'm going to do transform controls. So this one is a component 2. Most of them are component, by the way, but we can add it like that, and check that. This is the gizmo I told you about. That's what we call a gizmo, and you can play with it. Oh, we have some issues right here. So be careful with it. We have some issues that we are going to fix super easily, but I want to show you how to fix those. That's also why I chose this one as the second helper I want to show you. First issue, the position. I wanted the gizmo on the cube, and it's by default at the center of the scene. Second issue, when I try to move it, check that. It's moving, see, but the camera is also moving because the orbit control is moving when we drag and drop on the scene. So we have two issues to fix. Let's start with the position. Yeah, let's start with the position. I want the gizmo to be at the center of the cube. How do we do that? When writing mesh inside the transform controls, React 3 Fiber, we create an object inside another object. That's the rule I explained in the previous lessons. When you put something inside something, if it's an object, well, this object will be added to that object. And if I put another mesh or group on top of it, things will get nested inside other object, inside other object. That's how it works. So we created that transform controls, just like that. Just watch my screen. I'm going to remove the mesh. It created that gizmo, so the transform control at the center of the scene. Then we put a mesh, and we ask the mesh to be offsetted on the x-axis right here. So it's going to add a mesh and move that mesh inside the parent. So it does things that we are asking. So it's just fine. But how can we fix that? I still want my gizmo to be at the center of the cube, and I want that cube to stay there. There are two solutions. First solution, since transform control is an object, it's a special object, it's a gizmo object, but it's still a Three.js object 3D. We can put that attribute on the transform controls like that. So the mesh is at the center, but the center of the parent, but the parent now is offsetted on the x-axis, and I can give it a reload, and now it's better. All right, it's working. You can do that. I like this solution, but there is an issue with that solution. I'm going to show you the second solution, and you will see that the second solution is a bit harder, but makes more sense. You will see why. The second solution consists on separating them completely, but reassociating them together using a reference, and we're going to do that. So first we separate them. So I'm going to take the mesh, follow me on that, and you put it outside. Don't forget to put back the position. Okay, the position, you put it back on the mesh. By the way, put the mesh before the transform control, because right now maybe they fixed it, maybe while you are doing it they fixed it, but if you put the transform control before, later there will be a bug that I can't explain. So put the mesh here and the transform control after. Okay, and since the transform control there is nothing inside, where we can auto close it like that. All right, so you separated them, the mesh is not inside the transform control, and we get that. So the transform control is at the center, the mesh is the cube mesh is there, and if we move the transform control, so the camera is still moving, but we're going to fix that right after, it doesn't move the mesh because the mesh is not associated with the transform control. So now we need to associate it again, and we're going to use a reference. All right, like we did in the previous lessons. First, we're going to import useRef from React, useRef from React, like that. And at the beginning of the experience lesson, we are going to create a reference to that. So it's going to be cube, because that's just my cube. If you prefer to write cubeRef, you can. Cube reference if you prefer to, but I'm just going to call it cube since it's just the cube. Equal useRef. All right, like in the previous lesson, first we create a reference, and do you remember how we use that reference on the cube? We need to use the ref attribute. So let's go. The cube is right here, and I'm going to add ref equal that reference. Oops, cube reference. So it's going to be the cube reference, like that. We save. We now have a reference to that mesh. Great. We now want to associate it with the transform control, and we can do that by using the object attribute. And we do object equal the cube. Check that. Now it's at the right place. They are separated. The transform control gizmo has been moved to the object. They are associated together because I can move them like this. Yes, the camera is still moving. We're going to fix that super easily, you will see. But now it's working. I like this solution better. It's a bit more complicated, as you can see, because we need the reference. First, we always need a bunch of reference because we are going to animate stuff, I don't know, change the color of the objects, etc. So anyway, we are going to have a bunch of reference anyway. And the second reason is that they are independent. That's something I really like. I can remove the transform controls like that. I just remove it from the GSX. It doesn't exist anymore in my scene, and it's working. With the previous solution, it was around the mesh, so we had to remove it on the top part, I mean the opening of the tag and the closing of the tag, and we also had to move the position back to the mesh, so it was a bit more messy. Things were dependent on each other. I'm not a big fan of that. You do whatever you want. It was just an example. The second issue, so I'm going to put back the transform like this. The second issue is that the camera is moving because of the orbit controls when I drag and drop. It's so easy to fix. Check that. We go on the orbit controls and we add make default, just like that. So in camel case, you add the make default attribute on the orbit controls, and it's fixed. What happened here? React 3 fiber, the Dray control, the Dray helpers, they know about that. They know about that issue. By doing make default, you are telling the whole React 3 fiber application that this is my default controls. And by doing that, helpers get access to it because they know that's the default one. Maybe for some reasons you have multiple controls. React 3 fiber can't assume that this is the main controls. So you have to tell React 3 fiber that this is my default controls. And by doing that, other helpers can access the default one and decide to deactivate it or not when necessary. So now that the transform controls knows that we have some controls, it will deactivate the controls when we are playing with the gizmo and activate them back when we are not playing with the controls so that we can move around. That's all. We just added make default on the default controls. So easy. Okay, by the way, the transform controls, it's from a 3JS, the base class is from a 3JS class, and we can also control the mods, like right here, we can move it like that. All right, that's cool. But we can also play with other mods, like if you want to play with the rotation, you do mod, and you do rotate, like this, and now we can rotate the cube, like that. And if you want to play with the scale, you play with the scale, like this. I'm going to reload, and we can do that. All right, cool. We're going to put back translate for now. Translate. Yeah, and you can give it a reload to reset the scale. That's all for the transform controls. By the way, like other helpers, I'm just showing you a bunch of attributes to practice, but check the documentation. There are always more attributes and parameters and cool things to do. I just want you to discover the basics, have some fun, and not spend too much time on that lesson. Next one is the pivot controls. So we had the transform controls, and now we have the pivot controls. What's that? It's an alternative solution to the transform controls. We have access to different features, but also it looks super good. Why do we want a transform controls? So a gizmo that looks good. Well, this one looks a bit like a developer debug thing. You don't want this one for your clients, for the final user, because it doesn't look really good. It's very efficient, it's functional, but it doesn't look really good. What if you're creating, I don't know, an application when you can place characters, move things in a scene? Maybe it's a kitchen, furniture, configurator, and you want your users to be able to put a sink there, to put some furnitures there. It has to look good. You want an application that people want to use. So how do we do that? Where we can use the pivot controls, because you will see it looks much better, and we can personalize a lot of things inside this one. So it's a super cool one. By the way, it's quite recent, and we are starting to see it a bit everywhere, and I'm not sure you can use it without React 3 Fiber. I might be wrong, but I think it's you have to use React 3 Fiber and Dre to get access to this one. So let's go. Too much spoiler. Let's practice now. We're going to import it. Pivot controls. So there is a transform control and there is the pivot control. It's not about pivoting. You can also move it, you will see. So I'm importing the pivot controls and I'm going to add it around the orange sphere. Okay, so it's this one, the first mesh. I'm going to do pivot controls like that, and I'm going to wrap the whole mesh in it. As always, put the right indentation and don't be silly. Indent the proper way and check that out. Here you go. So we can move the sphere, we can rotate it. So the center of the pivot is not right yet. We're going to fix that. But first, I want you to have some fun with it and check that it looks good, and it's going to look even better. You're going to be able to personalize it. I like the default transform controls, but I like this one much better. All right. Pivot controls doesn't work as a group like for the transform controls. All right, what I told you with the transform controls about it's an object inside another object, it's not the case for the pivot controls. The pivot controls is not a group. I know it looks like a group, but it's not the case, which I think is a bit better because about the scene graph and things like that, it doesn't really make sense. So I think it's a bit better. So the question is, how do we center it on the object, or center it, or maybe we want it to be, I don't know, on this top left corner or whatever. How do we move it? We need to use the anchor attributes, and we see how the anchor works. It's really cool. So on the orbit controls, we're going to put a default value of an array with 0, 0, 0 in it, and you will probably understand after using it. So I'm going to add that anchor attribute right here. I'm going to send it an array, and I'm going to put 0, 0, 0 like that. And check the result. I'm going to save, and here you go. So it's not perfect. There is a small bug. I think they fixed it in the latest version of Dre. So if you update Dre, this should not happen, but we will consider that the bug is still here and we're going to fix it. Don't worry, it's going to be super easy. But doing 0, 0, put it at the center. You can still see little of it, like the outside arrows, you can see them, so it's at the center. The pivot control visibility works like any object in the scene and will be hidden if it's behind other objects. To force it to render on top of the scene, we can use its depth test attributes. Just like classic materials in 3GS, we can tell it to not take care about the depth of other things, meaning that when it's going to draw, it's going to draw on top of what has already been drawn, regardless of the other objects in the scene. So we can do that on the pivot controls. You can add some line breaks if you want. I prefer to have some line breaks so that it fits on the width of my editor. And I can put depth test false. And by doing that, it's going to render on top of everything. Nice, easy. Next, about that anchor thing. So I told you to put 0, 0, 0. What are those? Usually when you have 3 values like that, it's for X, Y, and Z. And you can test it by putting, I don't know, maybe 1 like this. Okay, it's on the top. Does this mean that those are units? Not exactly. Those are relative values to the object, meaning that if you put 1, it's going to be the top of the object, regardless of the size of the object. And you can test that. Like if you put a scale, you don't have to do it, I can just show you, but if you want to do it with me, be my guest. You can put 2 on the scale and check that it's still at the top. So the anchor is always 1, but the scale is 2. So now it's probably like 2 units high, I guess. And the gizmo is at the top. So it's a relative position. You can have fun with it. I'm going to put back the scale at the default scale at 1. You can put, yeah, we can move it. Okay, we remove the scale. Yeah, you can put, I don't know, like 1, 1, 1. So it's going to be on the X, Y, and Z. And as you can see on the X, see, it's perfectly aligned with the object. On the Y, yep, it's perfectly on the top. And on the Z, like that, it's perfectly in line on the Z. Easy. And you can also put get outside of the limitation like this, and see it's 2 units. I mean 2 times the 8, always relative to the sphere. And you can put negative values if you want. All right, so easy. I spent too much time on this one. Let's put back. Let me check 0, 0, 0. Yeah, let's put it at the center again, like that. All right, cool. We have more to see about the pivot controls because it's super cool. And I told you that you can personalize it so that you can use it in production for your users. You can personalize it, and we are going to see only 3 attributes. I think there is even more attributes. First of all, about, no, we are going to see, I think, 5 attributes. First of all, about the style, we can change the thickness of the lines. So it's going to be the line width. You can provide a number, and I'm going to put 4. And it's the same value, so I'm going to put 1. So 1 is I think 1 fragment, 1 pixel maybe. Anyway, if you want a thick gizmo, you can put 10. I'm going to put back 4 because 4 is just fine. You can change the color, so axis colors with an S, and you're going to provide an array, and you're going to provide 3 values. And I already prepared some colors, so you can write them with me. If you want to have fun, you can put your own values. The default one looks really good, but if you want something that matches your style, the style of your interface, etc., you can do it. So I'm going to put this one, FF. For the second one, FF4D 6D, and for the last one is going to be 78E582, like that. And check that. Nice. A bit more like pastel. Maybe it fits the style of your website. I don't know. And finally, you can play with the scale. So the scale we're going to put, I don't know, like 2. What do we get? Okay, it's twice the size. So I guess the default one, well, is 1. Nice. So if you put 2, it's bigger. Okay, cool. Next, by default, the pivot controls, we have a perspective. Check the transform controls. When I move away, the size stays the same compared to your screen. But for the pivot controls, the size is in perspective, meaning that if you go away, it's going to be smaller. Which is funny because the size of the thickness of the lines will stay the same. See, it's 4 pixels, so it looks a bit chubby right here. and but the size of the whole gizmo will have the perspective. So anyway, we can control that. You can control that by adding fixed and setting it to true. Be careful, there will be a small bug here. So my gizmo is probably there. What just happened? By setting fix, you fix the size. And if you are far away, it will always be the same size compared to your screen. But the size, is now explained in that scale property right here. And those are pixels, meaning that our gizmo is currently 2 pixels big. So we need something a bit more relevant, like, I don't know, 100. And check that, the size stays the same. It's up to you what you prefer, if you want perspective or not. Next in the list, we are done with the pivot control. Use that pivot control, it's really cool. Your users will be able to play around. That's super cool. Next one is the HTML. What, HTML? Are we going to do some HTML inside React through Fiber? Why, yes, in some ways, yes. If you remember from the previous lessons, it's like the one we put, some what's the name, focus point on the helmet, the futuristic helmet. That's the idea. But right now, it's going to be just one helper that we add to the GSX and we are done. It's super easy, we'll see. So HTML, as always, I put the link, check the links if you want to see. There are many attributes. We're going to see just a few of them, and it will add some HTML content on top of our canvas, but it will follow the models in the 3D. You will understand. If you don't understand, just add it. You will understand what I mean by that. First, we import it. So it's HTML in a Pascal case. So the T, M, and L are in lowercase. Next, we're going to add it somewhere in the scene. I'm going to add it at the end. Why not? HTML. And I'm going to open it and close it so that I can put something inside like this. And check that. This is my HTML. Nothing too fancy, but now check that if I move the camera on the side, so you can use the right click or you can use shift and drag and drop. It stays here, just like if it was an object in the scene. All right, so that's super cool. We did what we had to do, like in, I don't know, maybe 20-30 minutes in the previous lessons by doing it manually. We did it in 2 lines of code. So nice, so handy. This HTML, we can add it to any object 3D. So it concerns a lot of objects. A mesh inherit from object 3D. I'm talking about the object 3D class from Three.js. A mesh inherit from object 3D. A group inherit from object 3D. Our transform controls inherit from object 3D, etc. So we can add this HTML to any object 3D. And we're going to add it inside the sphere. So it's the one inside the pivot controls, and not inside the pivot controls. It will work, but we want it inside the mesh, all right? Because you can put meshes inside meshes. I usually never do that because it's a bit messy, I think, to have meshes inside meshes. But you can totally do that if you want. But in our case, we're going to add the HTML inside the mesh, the sphere mesh. And as you can see, it sticks to the center of it because the position of the HTML is 0, 0, 0 by default. We're going to change that right after. But now if we move the sphere, it's working. So obviously the label is on top of it, but we're going to move the HTML anyway. So great, it's working, so easy. Okay. We can offset that text. So if we want to to move it away, we can do position, like any object 3D, it works the same. We send an array, and to that array we can provide the X, Y, and Z, just like that. And now it's on this part, and see, it's working. So on the X it was 1 unit, on the Y it was 1 unit, and on the Z it was 0, so it stays aligned like that. And we can move it around, and it's working. Nice. Next, class and style. You don't like that text, I don't like it too. Let's fix that and make it a bit better. We can add style to it, but we're going to add a class first in order to target it in CSS. All right, because right now, if you check the DOM on this one, you see that it's a div with some CSS applied to it, but we have no way to target it and to add something on top of it. So first, we're going to add a class on it, and to do that, we can use the wrapper class attribute. So let's go. On the HTML, I'm going to add some line breaks so that we can read it more clearly. like that. I'm going to do wrapper class equal, and I'm going to call it label, just like that. And now if you inspect that element, label right here, be careful, we have some nested divs by default. We have the label that will be here, and the actual element that contains the text is a div inside of it. In the CSS, so open your style.css file, we can target it, but what I like to do is not target the parent, I like to target the child, okay? You can target the parent, it should work just fine, but I like to keep the parent at the exact position. I know that it's kind of a very small, infinitely small div at the exact position, and then the label inside, I'm playing with this one. I think it's just more solid, more solid way to apply CSS to it. You do whatever you want. I think this code will work just fine if you apply it to the label itself. So what I'm going to do is target the label and then the div inside. And to make sure that I'm targeting the first div inside, you can add a greater than. Do we say greater than? Bigger than? I don't know. I mean, you get it. This character here. And in there, I'm going to be super lazy and copy and paste that while you're writing it. I'm waiting. Go ahead. You can copy it from the text below. Anyway, I'm going to explain it quickly. So we put a font family, Helvetica Arial. Wasn't very inspired. Position absolute, I think it's already the case by default, but that makes it clear for another developer that arrives on the project. A background, but with a smaller alpha, because you can do that in CSS. If you specify more values in there, it will control the alpha, so the background will be black but with a smaller alpha. A white text so that we see it on the black background, some padding so that we have it's not too tight inside the div, white space, no wrap so that it stays on one line in case you have multiple words. Overflow hidden, I think this one is not necessary. Border radius so that the border is round, and user select none so that we can't select it, because check that, I'm trying to click on it, I can't click on it. All right, you do whatever you want. That's just a quick example. By the way, we can write something else in it. Yeah, I forgot to change the text. Let's change the text inside. You can put whatever you want. You can put your name if you want, and if you want to add some line breaks here too, you can do that. Okay, I'm going to put like this. Nice, that's a sphere. Did you know that this is a sphere? Now you know. Next, I'm going to save the style. I think I already did it anyway. And it's working. So, next in the list, if you rotate around and try to figure out where is the pivot point of that label, you can see that it's over there. See my cursor? Right here. It seems to be rotating around that, which is just fine. But if we move it like that, well, it's a bit too much on top of the sphere. What I want is that this point here is the center of the label. And you can do that by adding to the HTML tag center. So convenient. So it moved, and now the center of the pivot center of the HTML element is where my cursor is right now. So it's the center of the div. I can do that. See, it's up to you. Do whatever you want. If you don't like this one, you don't do it. Next, if I do that, see, it's too big. By default, there is no perspective applied to that element. We can control that by adding a distance factor, and you can choose the value. I'm going to put 8 because it's 8 in the lesson, and check that. So now it's big, and now it's small, and now it's big. Nice. And if you could put a smaller value, like, I don't know, like 3, I reload the page. By default, it's smaller, like that. So you always have the perspective. It looks like it's part of the 3D scene, but it gets smaller when the camera moves away. Okay, nice. Maybe I would just put 6 so that it's not too big because my screen is a bit small. You put whatever value you want for this one. We can hide it when objects are in front of it. So right now, check that. If I move the cube right here, it's always visible. It's not going to be masked. By occluding, I don't mean that. Check where is my camera right here. Check that angle. It's not going to hide just this part here, and we keep this part visible. It's going to be a bit more simple, meaning that it will be visible here, and it will be fully hidden here. right? If the center is occluded by some object, it will hide. If not, it will be fully visible. That's the idea of occluding. But first, we need to provide it what object should be able to occlude it, meaning that we are going to need some references. We already have a reference to the cube. Now we need a reference to the sphere because I also want the sphere to be able to occlude it when I do this. I don't care for the floor because it doesn't make sense to have the camera below it. If you want to have fun with the floor and occlude the label with the floor, you will see you can do it in 2 lines of code. So let's go. We need some references. We already have useRef from React that we use for the cube, and we're going to create, you can do it by the way if you want to try, don't check the slide right here, create a reference to the sphere, and that's all. Create a reference to the sphere. So const sphere equal use ref, and then we associate it with the sphere. So the sphere is the one inside the pivot controls, I think so. It's going to be ref equal, and we provide the reference like that. All right, cool. Next, we have a reference to the sphere, we have a reference to the cube. We're going to provide those 2 references as an array to the occlude attribute. So right here we do occlude equal, and we say sphere cube, like that. And check that, I'm going to reload, I'm going to move the camera like this, and it's hidden. I'm going to move the camera like this, check the label, check the HTML, and it's hidden. That's all. You can obviously add a better animation, something with spring or whatever, some easing with an elastic effect. You do whatever you want. We have other helpers to see, so we are going to stop there, but you get the idea. Next one is crazy awesome. This one is super complex, but so easy to implement, and it will change your life, like really. So first, let me explain something. I'm talking about adding text in the 3D. We already know how to do that by using a 3D text geometry. Remember from the previous lessons, that was one of the kind of real project we did. We created a 3D text using the 3D text geometry class in native 3JS. The problem by doing that is that first we can notice polygons. Like when you get smaller to it, you will see those polygons. The second issue is that it takes a lot of CPU resources, especially if you want to add a bunch of polygons so that we can't see those polygons, where it will take longer to create. And sometimes you can have a freeze, like 1 second freeze at the beginning of the experience because it's generating that huge geometry. Some fonts won't look very good, all right, because it's creating some bevel. There are some algorithm running so that we get a good looking font, but some font, like complex fonts, won't look good. And it doesn't support line breaks. If you want to create multiple lines, you have to create multiple geometries. We are going to see a new solution, a good alternative that is named SDF fonts. Maybe you've heard of it. Maybe you've heard of SDF in general. Let me explain to you. By the way, we don't need to understand the technique I'm going to explain to you. Okay, I'm going to try to explain to you what is SDF. It's just for the sake of learning. The helper we want to add, we can add it with just 2 lines of code and we are done, and we could skip to the next helper. But I want to teach you this because I think that SDF is so cool. It's such a cool concept, and I want you to learn a bit more about it. You don't have to learn that. If you don't understand this part, it's fine. Just try to gather as much knowledge as possible. So first, SDF stands for Signed Distance Field, which doesn't help at all, and is usually used in fragment shaders to draw shapes. You can do much more with SDF SDF, but usually we use it to draw shapes, and it's going to be the case right now with the fonts. But first I'm going to focus on SDF, then SDF fonts, and then we just use that helper and see how good it looks. So the idea of SDF, just SDF, is that we send a 2D or 3D point, because we can use SDF in 2D context or 3D context. If you just want to draw on a plane, it's going to be in 2D. So you send 2D coordinates, and there will be a SDF shape function that will tell you how far that point is from that shape. Let me do some drawings to explain to you. Let's imagine that we have something like that. Okay, like that, and like that. We want to draw a shape. Let's say that this shape is something like that, all right? Any shape for now, we don't really care. We are going to create a function, so the SDF function, that will tell you, like this point, you provide a point, like this one, how far, I'm going to use green for this one. This point, that function will tell you how far you are from the shape, all right? And it's gonna be that distance. It's kind of the minimal distance toward that shape. It will tell you you are at, I don't know, like 1 unit, 0.2 units or whatever. And if you provide, I don't know, another one, like a point right here, the closest part is somewhere over there, I think, something like that. And it will provide you that value, all right? It returns just a float value, like how far are you from that shape. This kind of shape is super hard to create, but there are easier shape. Like, yeah, there is many possible shapes. So if you can express them mathematically, you are good to go, all right? Let me give you a very simple example with a disk, how to draw a disk. So that shape was super complex. Let me show you another shape, much easier to understand. So I'm going to draw another one here, something like that, something like that, something like that, and something like that. If you want to draw a circle, so I won't be able to draw a circle, okay, imagine it's something like that. The center of the circle, we imagine it's here. You can obviously change that. You will provide a point right here. And how do we know how far we are? If you want to draw a circle right here, how do we know how far we are from that circle? Well, it's quite simple. You take the center of the circle, which is right here, and you draw a line right here, and you get the distance to it. And if the value you get, I don't know, like it's 2. If you want to draw a circle which has a radius of 1, if that value is below 1, you are inside the circle. If that value is above 1, you are outside of the circle. That's how you draw a circle, I mean a disk, using SDF. The function, you provide the center of the disk, you provide the radius of the disk. So for us, let's say it's going to be 1. So let's say it's going to be like that. So it's going to be 1, like this, to that function. And if the point you're testing, so that's the one, is the distance between that point and the center of the disk is greater than 1, we are outside. Okay, we are in this part, like there. So we don't draw anything. And if we test something right here, so as you can see, it's inside the disk, but the distance between those is below the radius of the disk, we are inside the disk. So we draw it. And just like that, you can draw a circle. So these points will be inside, 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 this point will be inside. And all of those, you test the distance, it's greater than 1, so it's outside, 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 and those won't be drawn. And just like that, you can draw a disk. Why the disk? Because it's the simplest one. Now imagine that you draw more complex shape, like how can you draw a triangle? That's where things get a bit more complicated. How do you draw, I don't know, a trapeze? More complicated. How do you draw, I don't know, like a star, something like that, okay? I can't draw a star, as you can see. Anyway, that's the idea. And we actually already did that in the shader lesson, the shader patterns lesson earlier in the course. We drew some disks. Those are SDF functions. We didn't put them in a function, but if you separate it and put that in a function that you provide the center of the disk, the radius of the disk, and it returns the distance to that disk, well, you created a SDF function. That's the idea. Let's get back to the lesson. Where are they? Yeah, right here. So just explain what I just did here with the Photoshop, the drawing. Yeah, we said that already. So it gets more complicated for more complex shapes. And we are talking about 2D shapes, but as I told you earlier, we can also have 3D shapes. And it's even more complicated. Like for a sphere, it's kind of the same as the disk, but for like 3D cube, and the cubes can be rotated around, it gets super complicated. There is this guy. Inigo Quiles. Maybe you've heard of him. He's so good. That's the kind of guy which are both super motivating and totally demotivating, because super motivating, wow, we can do that. And then you discover how complex it is and you're like, I will never be able to do that. So that's the kind of guy. So follow him on Twitter. I've just added to the slide his name on Twitter. We'll also have the slides in the links with the lesson. He posts a bunch of things about algorithm, WebGL, and he also posts some tutorials, very good tutorials. And he created 2 articles, one for 2D SDF function and one for 3D SDF functions. And see, you get the idea. You get the distance using that function. Here, you get the distance of, let's say, that point to the center of that, circle. Circle or disk is a bit the same. You can have rounded box and check the code. I can't explain that code. You can have box, you can have oriented box if you want to be able to rotate that box, some lines, some weird shapes, triangles, pentagon, etc., etc., etc. And it works in 3D too. All right, you get you can get the distance from a 3D point to a cube, a box, a sphere, a torus, and more complex shape. Just check those shapes like a Death Star. What the hell? Okay. Anyway, let's move forward. I'm spending way too much time on this one. You get the idea of SDF. Those are functions that return the distance of a point to a shape. It can be 2D or 3D. But now, what about the SDF fonts? You get, it's the same idea. For font, it's even more, but for font, it's even more complex because you can't express a font mathematically. I'm going to do one more drawing, so it's going to be a third box. I think that's the last box we do in this lesson. Something like that, something like that, and something like that. So imagine I'm going to create a simple character, all right? It's going to be, let's say a T, all right? It's going to be a T, but the T is going to be a bit more funnier, like something like that. And it's going to be like that because I have a kind of a special font with some curves here and there. If you try to express characters like this, and there is a bunch of characters that has been created by an artist, a font artist, you can't express that mathematically. All right, even if it's a very geometrical font, you will see that sometimes some points are moved slightly here and there, and it's impossible to, almost impossible to get a mathematical function that will return the distance of a point. So let's say like this point here toward the closest part of that font. All right, it's almost impossible. So what did I do to fix that? Because that would be so cool to be able to draw some text, let's say just one character for now, but to be able to draw a character using SDF. Developers have created scripts that generate a texture, so a bunch of texture, containing the distance information for each character of a font. So we are focusing on a T. All right, so we are T, I know, but that's the idea. We are focusing on a T. And instead of having a function that returns the distance of any point to that T, it will be a texture. And in that textures, which looks a bit weird, it's a bunch of gradient, it's almost abstract art, you just provide like a point, like the one we just have here. And in the pixel of that texture, so it's going to be a texture with a bunch of pixels like this. Let me create a grid. Okay, like that. So it's a bunch of pixels. Okay, like that. This pixel here, the textures will say that this pixel is at this distance from the character. So it's going to be much more precise than that. I don't have much pixels, but that's the idea. So it's saved in a texture. So it's a bunch of scripts that are doing that. We can then use that texture to indicate the distance between the fragment we are drawing and the supposed character. So if you want to draw this one, we know that it's outside. If you want to draw this one here, we know that it's outside. So let me put some red stuff. So this one is outside, this one is outside, this one is outside. And I'm going to use some green. This one is inside, okay? This one is inside, this one is inside, this was inside, 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 inside. Let's say that those are inside, and you get the idea. And obviously it's much more precise. So this texture is the resolution is way too low. If the distance is closer to a specific value, we draw the text, otherwise we draw nothing. And just like that, we can draw SDF fonts. So it works for a character, but it works for full text. And we do that for A, B, C, D, E, F, G, and we also generate the uppercase version, and we can also generate the special characters, like, I don't know, the comma, the exclamation mark, the any character that we want to use in our experience, and it will generate that texture, and we will be able to use that texture. It gets a bit complicated, I know, but that's so interesting. The value saved in the texture is the distance between the point we are drawing and the character. Okay, it's not just is it in the character or not. The texture is the distance between this pixel and the center of the character. Okay, this means that we can do more than just showing the text or not. We can also like change the thickness, because we can decide that this texture, let me use another color, this text, we want it to be thicker. Well, we just have the distance from that pixel to the center of the character, meaning that we can draw something bigger. Let me use another color. We can draw the text like that if we want. We just get the distance. We do whatever we want with it. We can change the threshold that will draw the character or not. We can add an outline. Yeah, just by using that distance, we can add an outline. We can add some blur to it, like a radial blur going out from the text. We can draw huge text. We can have a lot of words because we are using the same character. Like you create that atlas textures with A, B, C, etc. And then you can create like a full paragraph or full page with a bunch of words and sentences in the same atlas. Next. By the way, the natural interpolation between pixels makes the techniques work with huge text. So you can make the text bigger, bigger, and bigger, and bigger. Since the value is interpolated, like if we take, let's say, this value here, right here. If we put it there and then we compare this one, well, I don't know, we get, this is it's far from 1, 2, 3. Okay, so this one is from the center, so the orange line, it's 3 units. Okay, this one here, okay, so this one is 1, 2 units. But what about between those right here? See, I'm between the previous ones. So I had one here, I had one here. Now I want to know this one in between. If you understood how shaders and texture picking, etc., texture sampling, is working, the value is interpolated between pixels. So this one, if this one was 2 and this one was 3, the one here will be 2.5 automatically, because the values are being interpolated, meaning that a quite small resolution texture for that SDF font will work even with huge text. It's super cool. And its performance, the performance are just great. So it was quite complex. Let me reassure you, the heavy lifting has been done by other developers. Thanks to them, we can just use those. So some developers have done most of the heavy lifting in the 3K. I'm probably saying it wrong, but I'm going to say 3K, Troika maybe, library, and more precisely the Troika 3 text. And I put the link as always. If you're curious, just check that. They have some great examples. See, some huge text, some long text, and it just works, and the performances are just fine. And Dre, obviously, we are talking about Dre in this lesson. Maybe you forgot because I've been talking for like 15 minutes. Dre is implementing that solution in the text helper. So we can just use the text helper. So yeah, you don't need to understand everything I just said. It was just like a bonus. I'm no expert in SDF and SDF font, but I wanted you to show you the technique, which is super cool. So let's go. Let's implement it. I hope you have some brain left after those drawing and stuff. So let's go back to our code. We're going to import text. So we just write text like this, and we are going to, let me put that tablet away. And in our GSX, I'm going to put it at the end, but I think we are moving it a bit later. I can put I love R3F in uppercase. Why not? And check that. Nothing on screen. Well, check at the center right here. It's working. So just by default, you import the helper, you add it to your scene, you put any text in it, and it's working. The content that you put inside of it will be used as the text you want to add to your scene. The default font is Roboto that you can find on Google Font, and it's downloaded automatically from the Font Google Fonts CDN. All right, there is nothing in the public. I didn't have to put the Roboto font in the public folder, but we can also use our own fonts. And if you check the public folder, there is a bangers. It's a font. It's a kind of a silly font, but I really like this one. It's a font that I've downloaded. It's a WAV file. We're going to talk about that, but I just want you to see that you can personalize it. So if you put font, because the Roboto, you don't like the Roboto, you want to put something else, you do font, and you load that file. So bangers-v20. I kept the original name, so it's a bit long to write. Regular, make sure you have the exact same path as me, and you save, and now you have the new font. All right, zoom in a little. By default, it's a super small text. You have to zoom in a little. And check that. We're going to make it bigger, obviously, and change the color. Yeah, I like this font. It's a funny font. Looks like a bit like comics. Yeah, by the way, a quick reminder that files provided in the public directory are accessible if they are in the same folder as the website. I'm not talking about the SRC folder. The idea is that you can access those. Like if I put bangers, what's the name? Right here, I'm not going to do it, and you don't have to do it, but if I put this here, it's going to download the font. All right, that's the idea. Everything we put in the public folder is accessible like if you put it there, which is why we had to write / like this. Okay, we didn't have to put like I want to go up and then go inside the public folder. Don't do that. If you want to just get access to files as they are, you put them in the public folder and you can access them like if it was right after the website domain, like this. Next, yeah, we saw that. Troika supports WAV, TTF, and OTF formats. So you can use any of those formats, but I recommend to use WAV because I think it's the lighter one. So let's try to use WAV as much as possible. You can try to convert fonts. Like, I don't know, you get a font that you want to use, but it's not the right format. I've put two links, so there is Transfonter and Font Squirrel that will try to convert your font. Be careful, it can't convert every font, and also some fonts have licenses on them, and those websites are forbidden to convert those. And obviously, make sure that you have the right to use the fonts. As always, I will give you a quick reminder of that right after. You can find a lot of fonts on Google Fonts. I'm quite sure you know this website. There are hundreds and hundreds of fonts on Google Fonts. But the problem is that it's a bit hard to download them, but more specifically download them in the right format. Like if you download the font, like, I don't know, this one, and I try to download the font family like this, what I get in there is not the WAV file. All right, but there is a website, so the name is Google Font Helper right here, this website, and you have the list of all the fonts from Google Font. So if you like the silk screen font, I chose it totally randomly. Here's the silk screen font. You don't have to do it. I just want you to see where to find a bunch of fonts, and from here you can download it, and there will be the WAV file in here. All right, so that's super convenient. You can do it. If you want to pause the video and try that, be my guest. Don't forget to check licenses. Yeah, I already warned you about that. Please be serious about that. You need to make sure that you have the right to use a font. It's not because the font is online on some weird website that you can use it for your project, and more specifically for your online project. So make sure you have the right to use the font, just like you can't use any model, any images. You have to make sure that you have the license let you do that. Google Fonts fonts are provided under the Seal Open Font License 1.1. I'm no license expert or Apache, by the way, but those are just fine. You can use those fonts. It's okay. So you can use them freely. So let's go. The text is super small. So I like the font now. I guess you don't like my font, but I really like this one. It's a funny font. You can change the size of it by doing font size and put some other value. I'm going to put 1. And as you can see, the text is much bigger. And we can change the color. You can do color equal. And I'm going to provide a salmon like that. And we have the salmon color. As you can see, compared to the geometry font, there is no depth. All right, that's kind of the price you pay with it, but the performances are much bigger, and you can zoom in. Check that. I'm so much zoomed in maybe the line is not perfect anymore, but see how much zoomed in I am, and it's just fine, and the performances are really good. We can provide our own material, so if you put a color like that, you get it's a basic color that doesn't react to light. If you want it to react to light, you can put a mesh standard material. In our case, we're going to put something else. I think, it's the mesh normal material. It's just an example, so mesh normal material. You can auto-close it like that. Now it's using the mesh normal material. It's the one that it depends on the orientation of the face compared to the camera, and the color would change a little. Like that. Silly example. Anyway, we're going to remove this one. I like the default one. So yeah, next. Text works like most objects in the scene, and we can play with its position, rotation, and scale. Nice. So we can put those attributes, the usual attributes, position, rotation, and scale, right here. So if I want it to move up a little, I can do position.y equal, and I provide 2. Now it's above it. And you can put some transform controls. You can add some HTML in it. You can use the pivot control on it. Everything works just the same. You can use the rotation and the scale too, but we are not going to do it. Next, by the way, we can also use some automatic line breaks, because it works with huge text and text with the line breaks at some point, so that you get it's not like a long line, infinite long line. To do that, we can provide a max width. And will it work with this text? I'm not sure. 2, yeah, it's working with the line width of 2. I think it's 2 units, and 2 units should be over there. So the text cuts, and there is a automatic line breaks, and the R3F just went below. So handy, convenient. By the way, by default, I think it's aligned on the left like this. The text is aligned on the left, so we can change that by adding text align equal. I'm going to provide a string, so it's going to be center, like that, right? They are centered. Nice. There is tons more of attributes. We are not going to discover them, but I put the link to the documentation. You can just check that documentation and see letter spacing, line height, fill opacity, direction, etc., etc. You can control all of those. Next, we are done with the text. There was quite a big section. I hope it wasn't too much boring. Next is the float. Super easy, really cool. I really like this one. It can add a lot to a scene, especially when the scene is too static, because the float helper, we make the object float like this. See my hand? It's gonna float like a balloon in the air, or like the overboard from Back to the Future, the one that is floating above the floor like that. So you can just add that using the float helper. So let's go. We're going to import it. I'm going to close the sidebar and import float from React 3 tray. Yeah, this line is going to be is getting quite long. My bad. And we're going to add it on the text. Why not? So you're going to wrap the text with it like that and like that. And now check the text. I'm going to zoom in a little. It's moving and it's doing that. I don't know what they use exactly for the animation. Maybe it's a bunch of sinus, cosinus. I'm not sure. Maybe they are using some pairing noise, but anyway, it looks really natural. Something is floating around. And you can obviously have some fun with the attributes if you want it to be a bit faster. So I'm going to add some line breaks. I'm going to add a speed. I can put it to 5. Now it's faster, which is a bit stressful, but why not if you want to do that? We can change the intensity. I think we are going to lower it a bit. Actually, it's higher. So if you put, I don't know, like 10, it's going to move a lot. So this is the position intensity. You can also control the rotation intensity. And there is a bunch more of parameters. I'll let you discover them on your own. Next one, the mesh reflector material, because we've seen some kind of debug things. We've seen some HTML things. We've seen some cool way to put the text and to animate stuff, but it's also about materials. And there is a cool materials, which is a mesh reflector material. And yes, it's about having reflections. And it's going to be so easy. Reflections in WebGL are always complicated, but mesh reflector material is not. Sounds like an advertising. So let's go. Mesh reflector, so we import it as always, mesh reflector material. And since it's a material, we have to put it instead of the materials of your meshes. So we're going to do it on the floor. So the currently green floor. Right here, I'm going to remove that. I can just comment it. It's up to you. And I'm going, by default, there is a white kind of gray floor. So we're going to put that mesh reflector material and check that this one is in Pascal case. All right. This is the auto-generated one. See? Camel case, the M is lowercase, but this one is kind of a special one that we imported from React 3 Dray. So we have to keep the same nomenclature, so it's with the uppercase M. And we just add that, and maybe you can already notice the difference. See that? We can see the reflection. By default, it's a slight dim reflection, but we can obviously control that. By the way, yes, it won't work with non-planar meshes. So if you add it, let's say, to the sphere, maybe pause the video and give it a try, you're going to be disappointed. So it works only on planar meshes, so like the floor. First of all, we can change the resolution, because if you watch on your computer, we'll see that we can distinguish some pixels in there, so you can increase the resolution. Obviously, the higher, the worse the performances, but it depends on your scene. Just keep an eye on performances. We will see later how to keep a good eye on performances, but not in this lesson. I think it's the next one. So I put 512, which I think it's maybe twice the default one. And now we can't notice the pixels too much. If you want more, you just add more. Next, we can control the blurriness of it. By default, I think there is a very slight blur. I'm not sure, maybe it's there is no blur. You're gonna see the results. So we can put a blur and put some values. I have no idea what are those values. So we just put 1000 like that. And then we need to put something else, which is a mix blur, which is it's going to mix between the non-blur version and the blur version. So we want a fully blurred version. So we're going to put 1. So it's between 0 and 1. And see now, the reflection is fully blurred. And if you put 0, there is no blur. So your blur is not being used at all. So I like to have it really blurred like this. Next, we can't see it too much, but we can control that, and we can add the mirror attribute. We can put, I don't know, like 0.5. I think it's between 0 and 1. 0.5 is half between. So if I put 0, we can't see it much. If I put 1, it's like a full mirror. So you can put 0.5 or whatever you want to do. It's up to what you want to create. You know what? I'm going to put a bit more because I really like this reflection. Next, we can also control the color. So it's going to be color equal, and we can put back the green yellow that we have on the floor, and it will look something like that. See? Super cool. It's not a very physically based realistic reflection, but if you want a quick reflection, like there is a mirror in your game and your character can just see himself on the mirror, you can totally use this one, and it looks really good. There is a bunch of other attributes. Feel free to check them out on the documentation. Going further, we are done. That's it. That's the last section. We haven't dug too much into the many helpers. All right, if I can show them to you again, there are so many helpers. It would take a full day to cover them all, and it would not even be interesting. We haven't dug too much into the attributes too, because I just shown you some attributes to make things look a bit better and to have some fun. But there are many more attributes on every helpers, and even the helpers we have seen together. So my recommendation is to just roam by yourself, check them out, spend some time on them. You can test them using the storybooks things. Just click on those. You will see that you can test those codes and have some fun, tweak the parameters, so that you know that they exist. And when you need it, you will just remember, oh yeah, I know there is a helper for that. So just do that before switching to the next lesson. Check those helpers, and it will be super inspiring. And by the way, this library keeps evolving every day. So yeah. Also, if you have ideas for new helpers, or you are creating components or hooks for your personal project and want to share, don't hesitate to propose them to the Dray repository, because this repository is evolving. The Poimenders collective is adding more and more helpers to it. You can participate. You are one pull request away to help many developers. And I will see you in the next lesson.